Hi guys, today I'm going to do the reactivity trends of group 2 metals. So I'm going to start off by introducing the idea of reducing agents. Reducing agents. Now, all group 2 metals are reducing agents because they reduce another species. So Ca will go to Ca2 plus 2E minus. So the calcium itself, the group 2 metal, is oxidized, but then the calcium reduces another species, whatever it's reacting with, which means that it's the reducing agent. Next, I'm going to be talking about the redox reaction with oxygen. So redox and O2. So this is pretty simple. A group 2 element reacts with oxygen to make the element plus an O. So if I did Mg plus O2, it would just go to MgO. And then obviously there's the case of balancing. And always remember to put your states in there, so that's gas and that is solid. And then, so we can find out if which ones are oxidized and which ones reduced, because here the magnesium would be plus the magnesium wouldn't be plus because it's an element of its own, so the magnesium would be 0, the oxygen would also be 0, but then the magnesium here, when it's combined with something else, it would be plus 2 because the oxygen is always minus 2 as well. It's also plus 2 because it's a group 2 metal, so it loses 2 electrons, so it's plus 2. Which means that since magnesium goes from 0 to plus 2, it is oxidized, and since oxygen goes from 0 to minus 2, it is reduced. So magnesium reduces the oxygen, which means that it's a reducing agent, like we said before. Next, we're doing the redox reaction with water and group 2 metals, obviously. So this time we can use strontium, I think that's what I'm using. Yeah, strontium. So if we do Sr plus H2O, that will always make the group 2 metal hydroxide. So it will go SrOH2. This is because you need the charge to balance out, and plus H2. So if you can just use this with any group 2 metal. So say the group 2 metal was M, you could just go M plus H2O goes to MOH2 plus H2. That is literally a universal thing that you can use for all group 2 metals. And then there is so what happens here is, again, we can look at the redox reaction here. So strontium 0, H2O, the oxygen is plus 1. Remember, you only not the oxygen. The hydrogen is plus 1. Remember, you only take into account the number of one hydrogen, but then the oxygen is minus 2. And then here, the oxygen is minus 2, and hydrogen is +1, obviously. So that's, you have to times it by 2. So -2 times 2 is -4, and then +1 times 2 equals 2. So that leaves us at -2. So what strontium would be +2 in order to balance the charges out. And then, of course, an element in itself is always 0. So here you can see that strontium is oxidized because it goes from 0 to +2. Oxygen is, in fact, stays the same, actually. Yeah, oxygen stays the same because it goes from 0 to 0. Oh gosh, there's lots of zeros there. And then hydrogen, if you look at this, hydrogen goes from +1 to, right, I know there was a long pause there because I was trying to check something, but it goes from +1 to 0, which means that it is reduced, obviously, but then it also goes from +1 to +1 in the strontium, so over here, so there's no change there. If you want to balance this, there's a 2 there as well. That's all solid. So solid, liquid, that's aqueous, and that is gas. Ooh, there we go. Next reaction is with dilute acids. So let's use magnesium again. This is just a normal standard MASH equation. So MaSH, metal plus acid makes salt plus hydrogen. So if you do Mg plus HCl goes to MgCl2 plus H2. And if you want to balance it, there we go. That's all you got to do. And bish bash bosh, it goes from 0. It goes from 0 to +2, and then it goes from +1 to, the hydrogen goes from +1 to 0. So magnesium is oxidized and hydrogen is reduced. Now the trend in reactivity of the group 2 atom metals, so if we went like Be, Mg, Ca, Sr, Ba and Ra, the reactivity increases down the group. This is because group 2 metals are trying to lose their outer shell electrons. As you go down the group, the atomic radii becomes much bigger, which outweighs the increase in nuclear charge, which makes it easier for the electrons to be lost in the outer shells. And also there's a lot more electron shielding because of all the electrons in between the nucleus and the outer shell that are repelling against the outermost electron. So the reactivity increases down the group. Down the group, things that also increase is solubility. The pH, and the alkalinity. These all increase down the group 2 periods. You can test for the solubility by adding a spatula of each group 2 oxide to water in a test tube, and shake the mixture. On the scale there is insufficient water to dissolve all the metal, so it should be much easier for barium oxide to dissolve than magnesium or beryllium oxide. Sorry, I was talking about oxide. This is hydroxide. So if there was beryllium hydroxide or magnesium hydroxide or calcium hydroxide, the solubility, the pH, the alkalinity all increase down the group. Now let's talk about oxides. Group 2 and oxide reactions with water. So it's group 2 oxides with water. So what happens is, let's use Ca, calcium. So calcium oxide plus water, it always makes a Ca plus 2 plus ion and a 2OH or minus ion. The group 2 hydroxides are only slightly soluble in water. When the solution becomes saturated any further, the metal and hydroxide ions will form a solid precipitate. So yeah. Now, 2 uses of group 2 metals is in agriculture. Calcium hydroxide is added to fields as lime to increase the pH of the acidic soils. The calcium hydroxide neutralizes acid in the soil, forming neutral water. Yeah. So when there's been a lot of acid rain due to pollution and stuff, if you use the calcium hydroxide, this will bring up the pH and level it out. Then there's also group 2 medicines in medicine. That's what I meant. Group 2 compounds in medicines. They usually use as antacids when the pH in your tummy is too low. Then you ingest antacids, which are group 2 bases, in order to bring the pH up. So if you go from MgOH2 plus HCl, which is the acid in your stomach, goes to MgCl2 plus H2O. Remember, always balance. And so it kind of neutralizes the reaction, and your tummy feels a lot better. So that was it for the reaction of group 2 metals. I hope that was helpful. I know this has been a bit of a dodgy video, but doing with the best I can.